So in this video, we're going to look at factoring with a lead coefficient greater than 1 for quadratics. Now, I already made a video previously where the lead coefficient was 1, and we learned that that mainly had to do with multiplication and addition and subtraction. But when the lead coefficient is greater than 1, it still has to do with multiplication, but it gets a little more complicated in the review step. So we use just an algebra device to help us. So notice that these problems have a 2, a 2, a 3, and a 5. And the first thing you should look at it is, do they have a GCF? And in this first problem, notice that they all, both A, B, and C, all share a common 2. And you must remove GCFs before you do any other factoring, because otherwise there could be more than one answer. So you have to take the GCF out so that there's only one answer. And so I take the GCF out of here and I get x squared. I take the GCF out of here and I get 4. I take the GCF out of here and I get -5. And then it's the exact same thing we did earlier where we're looking at multiplication tables. 5 has a multiplication table of only 1 times 5. We're worried in this problem about subtraction. So, okay, 1 minus 5 is -4. So I would then, in the next step, add in the parentheses like we had previously, put an x and an x here to get x squared, and then use the 1 in the 5 with subtraction. Remember that a subtraction is always made up of 1 addition and 1 subtraction sign. The order is what matters. If I want to get a -4, I put the negative here and the positive there because 1 minus 5 is -4. If you multiply all that back together, you'll get the original problem. And that multiplication step is what's so critical, because these, when you do these, you really have to worry about that multiplication, because there's actually 2 multiplication tables. Here I have 15, which is 1 times 15, and of course 3 times 5. But on the other side, I have 1 times 2. So that's the key, is understanding that there actually are 2 sets of multiplication tables that you need to get to 11. And the only way to really get this is to use some kind of device to get that middle term. Remember, the goal in factoring is to start with C and move this way to get B. But now we've added in an A. So the best way to do this is say, okay, A is 2 and 1, which in the world of factoring is 2x and x. That locks in the 2x squared term. So I have the 2x squared term locked in from the original problem. So now the question is, how do I get 15? Now, 15 can be obtained with either 3 times 5 or 1 times 15. I'm going to start with 3 and 5 to show you how that works, right? 3 times 5 is 15. And so I've now locked in, through doing this, the first and last term. I've locked in the A and the C. They're correct. So the question is B correct? And the way you do that is you carry out the multiplication. This is 3x. And this would be 10x, and then you ask yourself, does this add together to give you 11? Okay, and the answer in this case is no. So do you freak out? You do not, because there is more than one way I could have arranged the 3 and the 5. So what you do is you just simply erase, and you say to yourself, couldn't I have put the 3 here and the 5 there? So if I reverse that, I still have locked in the 15. It doesn't change this box or this box. But what happens now is 5 times x is 5x. And then 2x times 3x is now 6x. And now I have found that middle term that equals to 11x, right? So now you can see 2x squared plus 11x plus 15 is the original problem. And so that provides you your actual factorization. You just write down the things on the outside of the box, right? So here I have 2x, and here I have x, and here I have a 5 with a 2, and I have a 3. And we didn't put the fact that we used addition signs, though everything is addition. And so you would use addition. I started off with the easiest possible combination of addition and addition. So what do you do if you have addition and subtraction? Well, you use the same rules. Remember, addition could be 2 positives like I did here, but it also could be 2 negatives, right? And that's what I'll end up using in this one. So again, it's so helpful to have some kind of device to help organize your thoughts. Again, in this problem, we still have to say, okay, 3 is 1 times 3. And 4 could be 1 times 4 or 2 times 2. So why don't we start just like we did before by getting the first one laid out. So this is 3x and x, and that is going to give us 3x squared. So that's done. The 4 is either 1 times 4 or 2 times 2. So why don't we start this time with 1 times 4? Okay, so we know that we have the 4. Okay, so let's see what happens here. And we know from previously that it's going to be 2 negatives because 2 negatives multiply to a positive, but they add up to a negative. So this is actually going to be a -1 and a -4. And so when I put them together, I get negative x, and 3x times -4 is -12x. So the question is, when I add these together, does that give me 7? It doesn't. So then I'm going to try, and again, we're trying to get 7, -7. I'm going to try to flip them now. Okay, so we have it that way. What if I did 1 and 4 this way? So that would give me -4x and -3x. Look at that, I got 7. And it literally just comes up on you like that, which is what's so nice about it. Now, what would have happened if this didn't work? What if -4 times x, -4x, and 3 times -1, which is -3x? What would happen if these two things did not add up to -7x? Well, I had another factor. I could have used 2 and 2, which wouldn't work. But if 1 and 4 did work, sorry, if 1 and 4 didn't work, you just move to the next factor. You need to make sure you're using an eraser. All right, so again, the factorization is 3x and x, and then we have the -4 goes with the 3x, and the -1 goes with the x. The beauty is you don't need to check it because you sort of are checking it as you're doing it, and that's the beauty of using this method. Okay, so let's do the last one here. Now this one is the one that's going to have, as you can see, it has a minus. So in here, I'm going to be using a plus and a minus. And this takes the most work because we don't know, is it going to be plus and minus, or is it going to be minus and plus? And my advice is to stick to where you start with, or you might drive yourself crazy. I'll explain. So 5 is 1 times 5, which would be 5x and x. And 6 is 1 times 6 and 2 times 3. So why don't we start with 1 and 6? So we'll start with a 1 and we'll start with a 6. And we need to make it positive and negative. Here is my advice, and it's very important to hear this. Just make it always positive and minus, and you can deal with it being backwards after you finish. Okay, so let's see what I mean by that. Here we have 5x squared, so that's done. Here we have -6, 1 times -6, so that's done. So the question is the middle thing -13? So 5 times -6 is -30, and 1 times x is x. That clearly does not add to -13. So let's change it around, and this might be an example again where I have to move to the next number, and that's normal in factoring. It doesn't mean you're doing it wrong. It just means, you're working through the problem. So here I have 6x, positive 6x, and here I have -5x. So that would have given me 1 had this been the middle term. Okay, so 1 and 6 are basically off the list. I used all the possible combinations. And so what this does is it gives you a nice way to factor through the possibilities. So the other possibility is 2 and 3. And so that will give me -15x and 2x, positive 2x, which does in fact come out to the answer of -13. But let's say we got the wrong answer. I mean, that is the answer, as you can see, but we put those on there, randomly. Let's say we decided to do minus here and plus there. We still would get the correct number, but it would be the wrong sign. So let me show you how to deal with that. So 5 times 3 would give me 15x, and then -2 times x would give me -2x. This is adding up currently, right? When I add that up, it currently gives me 13x. So it's like the right answer, but the wrong sign. All you would do is just do this. Oh, this should be positive, and that should have been negative. And you just go change it, and then, okay, 15 and -15 and 2 make negative, so now I'm good. So you don't really have to worry about starting with the right plus or minus sign. You're worried about getting 13. And as long as you get this C value, you can just change those at the last minute to get it correct. So this one comes out to 5x plus 2. and then x minus 3. And this is the best method I've ever seen for factoring because there are many out there. There's one called grouping. There's one called guess and check. There's one called slide and divide. And this is called the box method. And the reason I like the box method the best is because you can see your answer as you're doing it. You're literally checking it. Remember up here, we use the box just to check. You're literally checking it as you're doing it. So if you learn this way, there's almost no way you can get it wrong, and it eventually becomes more efficient. The other ways require you to perform an algorithm without error. This method allows you to get it wrong and fix it so that you're never stuck. So if you know slide and divide, or you know grouping, my advice is to give this a try. Some students use grouping and they use this, and those kids are always gonna be okay because they always have a way to move on in factoring. Just don't ever give up, okay? One more thing, make sure you look for a GCF. Many times factoring problems with an a greater than 1 are actually a hidden a equal to 1 problem with a GCF. I can take any of these problems and multiply it by 4, and then I have a quote unquote new problem, or multiply it by 3. Here I just multiplied something by 2. So never worry about doing the bigger method until you have tried the easiest method, which is to see if there's a GCF. All right, I hope this video helped, and I hope that you learned something about